vantage point, that's an advantage of this class too, right? Is that we're actually embarking on the scientific process of trying to discover what we don't know, as opposed to most traditional classes that we take, right? Where it's somebody's up here droning on and on and on, telling us what we think we already do know. And so when we're trying to figure out stuff that we don't know, it is that essence of discovery or exploration. Christopher Columbus out on the ocean, trying to figure out where is that chunk of land that we're trying to find. And for the most part, you just spend a lot of time trying to sort it out, right? You're gonna sail left, sail right, change on the winds, and the hurricane comes and screws you all up, and you got to start over with a new paper, and you figure out you were on the, like that. That frustration is okay. That's normal. Unfortunately, I hate to be the bearer of bad news in that regard, but that means you're doing something cool, something novel, something original, and something unique, right? And originality is really cool, and good. You remember that was actually a major. That was one of the heaviest insults that was levied. And you guys remember the movie Good Will Hunting? Yeah, you remember the scene in the bar? It's like a really famous scene, and he catches the really, really swarmy Harvard student plagiarizing a book, and basically the big insult that he drops on him when he catches him plagiarizing, Matt Damon, that is, catches this other really swarmy, horrible guy plagiarizing. The biggest insult he drops on him is like, at least I won't be unoriginal, right? Which is like, might not think of that as an insult on the schoolyard playground, right? Like, you're unoriginal. But in science and this kind of stuff, that's kind of an insult. And I think that's one of the exciting parts about stuff like this, is that we get to explore and figure out new stuff. So hopefully you guys worked on that with trying to come up with some of your own hypotheses and explore stuff in the data. I was able to correspond with some of you guys about that. You guys had some pretty cool ideas, so I look forward to seeing what's up with that. So obviously towards that end, so we're not going to do a quiz today, so that you guys can focus on doing that, because I know it's going to take a lot of time, and it's going to take some frustration to hone some of those things out, because you guys have a lot that's being asked of you, just like I have a lot being asked of me. I got to teach research methods, how to write, how to read papers, how to analyze stuff, and how to actually do the technical work in EEG Lab and MATLAB, how to, and you guys have to do all that stuff too. So that, to have all that to do today, and then have to do a quiz, that's not cool. So unless you guys want one, Are you sure? We could cook one up.
Like homework.
Huh?
Like homework.
Homework? What do you mean, like give you homework now for later?
I mean, to do the quiz at home.
Well, if we give the quiz at home, then that means it'll have to be a little harder, right? If we do one now, it would have to be something that you could access off of your storage of memory. But if you don't want one, okay, I was going to give you an easy one. It would be easy points, but that's okay. Seriously, it would have been like basically points for showing up and having a pulse.
That sounds good.
Yeah, it sounds good now. We'll sort it out. So did everybody have a chance to finish that project? I know I've already gotten a couple emails of all that good stuff from some people. If you haven't had a chance to finish it, and you have finished that, and you have the chance to email it to me, that would be wonderful. So please take an opportunity to do that. Yeah.
Okay.
Yeah.
So we email it to you, and
Yes.
so email it to Ariel.
Let's do it.
Do you go?
It's okay if you emailed it to Ariel. If you get it, just forward it to me.
You want all of them from today?
Yeah, whatever the final product is today.
Okay, I'll download them all and put them.
Okay. Cool.
Have you wanted the ones from previous weeks?
No. I
You
mean,
just want the one today?
I want to see what we're ready with today.
Okay.
Okay,
I'll put them all in.
Yeah, I mean, if anybody would like personal feedback on the drafts before today, that hopefully you guys have corresponded with Ariel about.
Oh, so I don't have to agree with them ones today?
Huh?
Do you want me to grade the ones today?
I'll take a look at it.
Okay.
You're welcome.
Thank you.
So, email me if you want me to look at the old ones, but if you have something more up to date, all right, put your best foot forward, right? How's it going?
Good.
Either way, send it to me. If you sent it to her, she'll send it to me. Any questions with that stuff? Was there questions on things that came up while you were working on this? There had to be something, right?
I could form like a hypothesis.
What's that?
I could form like a hypothesis.
Okay. Okay, so sometimes it's
That's
tough.
the hardest part.
Yeah, sometimes it's hard to form a hypothesis and figure out like, what should I ask on this stuff? You know, we don't.
Especially when like I already have like the data. Like I'm used to like forming a hypothesis and then like making a method to answer it.
Of course.
But like going backwards is just really
It's really hard.
really different, yeah.
Yeah. So, I'm not bringing it off here. So what she said was one of the things that was sort of a struggle was forming a hypothesis to work with data that we already have, right? So usually the process that we envision in our minds is that we have our hypothesis and then we go out and collect the data for it, right? We think that we have a world that is not flat. That is our hypothesis. And so then we solicit funds from the King of Spain and we collect some brave sailors to sail across the ocean and find India by going west instead of east. Right? Our hypothesis is that we do not have a flat Earth, or that it is round, either way, right? But of course then stuff comes in and screws everything up, like this gigantic landmass called the Americas. And as explorers, we have to somehow adapt to that and figure out what the heck is going on. So now you have to start forming some new hypothesis after you've found data that you didn't necessarily expect. So yeah, that's a really hard thing. Let's see here. So I know you were able to come up with some hypotheses. How did you do that? What strategy or process did you think of that helped you towards that?
Well, I just found a process that I wanted to look at and then thought of a question that corresponded with it.
Like how?
Like I was wanting to look at non-conscious memory, so I was basic hypothesis is between control patients and patients in the medial temporal lobe, there would be no difference in their non-conscious memory processes. And then you just see if there are.
Yeah, so how'd you cook that up as an idea?
How did I actually do it?
Yeah.
I created scout maps between different latencies. So for one set of scout maps, it was just the mean amplitude for between 200 and 600 milliseconds, and then compared between both groups. And then the second set of scout maps was a average every 100 milliseconds from 0 milliseconds to 800 milliseconds. And the purpose of that is that we knew from a different study, I found that non-conscious memory was usually from 0 milliseconds to 800 milliseconds, and it usually activated the temporal lobe. And so I was just kind of looking at things I could find with that.
Cool. So if I can maybe paraphrase what you said, he said he was interested in non-conscious memory, which is something we have talked about zero in the class, right? So kind of came up with a new idea. So we haven't talked about this, but maybe we have a way to look at it. And so we've only talked about conscious forms of memory. We talked about recollection a little bit. We talked about familiarity, right? That time someone seems really familiar, can't quite put your finger on it. And another time something just jumps out at you, like you recollect all the details, the who, the what, the where, the when, why you know them, and all that kind of good jazz. That mental time travel, mental explosion of like all the rich details that weave our tapestries of the past comes back at hand. So instead, he didn't do any of that. He said, well, maybe we can try something different. What else might be in here? And so non-conscious memory, how the heck? So we had a conscious memory task, right? They had to give their conscious responding. How on earth do you study and reveal brain activity for non-conscious memory when they're giving you conscious memory reports? It's crazy a little bit, right? Any ideas?
when they aren't sure of the source memory or item memory at all?
Okay, so when they're not sure, so we had our confidence ratings, 1, 2, 3, 4, 5, right? And this could be sure that they remember. This could be sure that it's a new item. So you said maybe when they're not sure. Like that? Yeah, but so the problem with that, it's a good idea, but this is what we've already sort of attributed familiarity-based processing on, because it's consciously saying, yeah, it does seem familiar, I'm just not totally sure that I've seen it before. Right? So that's a good way to start. Any other ideas? Right? It's pretty tricky. It's a weird sort of like thought experiment. How do you measure non-conscious memory within a conscious memory task? And the answer I usually give people is that it is the same way that porcupines mate. Very carefully. Yeah. Okay. So check this out. It's pretty cool. So he actually already answered the question because he said what he looked at in the contrast. All right. So you said you looked at which bins?
I actually didn't say the bins, but I looked at the bins where...
Or what conditions?
The conditions where the patients missed a trial, and then subtracted the conditions where they correctly rejected a trial.
All right, cool. So he's talking about some labels now we can give to these memory conditions. One of the labels are something he said a miss, and another one that we call correct rejection. So I'll get to that in just a second. We'll explain a little bit about what each of those mean. And one of the things that he did say, though, was he subtracted those bins from each other, or one from another. And so one way to sort of like try to help that challenge of like, well, how do I come up with some new hypotheses, this and that I wanted to be able to help you guys with, and we'll continue to try to help you guys with as we move along, is remember I wrote that huge long bin operations file for everybody? It was like 354 bins of some god-awful number of comparisons. Yeah? Right? Now, which ones did we talk about in class? We pretty much only ever plotted bin 188 or something like that, right? Old 5 minus old 4, right? That means we have what? 354 minus 1 bin, which means 353 options left. And so what we can do is, to help sort of find some new hypotheses, is start looking at what some of those other bins are and pick one and see how it works. Yeah, so perfect. I mean, yeah, so that's kind of the idea. Now the challenge with that is you want to start strategically picking the right ones, right? You don't want to just be willy-nilly, like, oh, I want to compare blah to blah and have it be some obscure, useless thing. You want to start using your cognitive gears up in your head to start thinking, what would be a really useful way to leverage some conditions against each other to subtract and reveal some really insightful pattern of memory that we might be able to draw something from. Now, some of the tricks that I suggested to you guys too, is if you're really hard up on something like this, is you can follow some of the same conditions and comparisons that I made with the data and some of the papers that we referred to that have already been published with this data, but look at different time points. Right? So instead of looking at the post-stimulus effects that we've talked about, 300, 500, 500 to 800, you can look in that pre-stimulus period, which would be a completely new hypothesis. So you could basically incrementalize it and say, okay, if you're really stuck and really not sure about what we can make a totally new hypothesis on, let's use the exact conditions that we know somebody else has used before, and let's just look at a different place in time that could be influential and would, in particular, be something very novel of a cognitive process. Because if you're looking at brain activity for the same type of comparison, but before the stuff even shows up on the screen, that can't be memory, can it? Because you're not remembering. You can't remember what you're not seeing. And they're not predicting it accurately because there's 300 possibilities of what could be on the screen. We're looking at the average of hundreds of trials. So it couldn't have been an accurate prediction every single one of those times of what's coming up unless they're super clairvoyant, and in which case we got some really cool hypotheses to explore. Right? So it's a really easy thing to say, oh, well, Columbus already made his way to America. Let's get a second exploration. Let's follow the exact same map. Let's just follow his route that he did. And let's see if we can go a little further south to I don't know, Cuba from the Dominican Republic or wherever the spots are that he landed, right? So you can take the same stuff and then go, whoop, a little bit of change, and we're good. Let's talk a little bit about what he introduced a minute ago. Misses versus correct rejection. So this is a way to leverage a conscious memory task to tap into the unconscious mind. And this is where I get really excited too, because I do a little bit of this work myself, and I find it really fascinating independently as well, right? We're able to use this really creative strategy to tap into the unconscious mind and look at the biological activity involved with the unconscious mind. So that to me is pretty awesome. So let's talk a little bit about what we mean. So we have 5 options on our confidence scale of responding here. Markers. And we said that we can either, basically the scale is representing times that they're sure they remember something, that we'll call that, that's not good. Old, they say, and new, they say. Okay, so what we can do is we can start to categorize this. Okie doke. Check this out. Let's just see if we can categorize this in this way. So we can use a nice little box and grid. Can everybody see that? I know it's kind of faded. Yeah? Okay. We'll get rid of that too. So what we're going to have here is pretty much, this is what, well, we can do it either way. Let's say we're going to have our status here. What do I mean by status? What is the status of the item on the screen? What's its truthful essence? Not like a weird new age kind of thing, but is it really an old item from the study phase, or is it truly a new item from the test phase? Everybody on board with the concept here? Really basic. So let's say, is this really an old item, or is it really a new item? Now, what things are in reality doesn't always correspond to what we perceive them as, right? Sometimes we see things correctly, other times we see things incorrectly, and we think the Dominican Republic is India, like Christopher Columbus did at first, right? It happens, right? We give some mistakes. So, just because the status is something doesn't mean that we always correspond to it. Sometimes we can do it correctly. So what I'll put on this top part here is basically our, we'll just call it a response. Okay. Now, we can have 2 responses. Basically, if we ignore confidence for now, we can have 2 responses here. We can call it new, or we can call it old. Everybody on board? Okay, doesn't mean we're right. So let's just say that we call it old. So I'll put it around quotations, and I'll use the small letters instead of our big bold ones of what things really are. This is just what we think it is. Likewise, we might think and say that something's new. So, if something is really old, and you say it is really old, what's a phrase we can use to categorize that cognitive condition or behavioral response?
Recollection.
It might be recollection, but this says it's old too. So this counts. And this could be familiar, huh?
High confidence.
Good idea, but this is not. Well, this wouldn't be high confidence. So what I'm introducing actually is something novel of a concept called signal detection theory. We'll touch a little bit about this. So we're trying to detect signals, and the ideas for this actually come from the attacks on Pearl Harbor. Why the heck are we talking about attacks on Pearl Harbor from Japanese kamikazes when we're talking about trying to reveal biology of the unconscious mind? It's kind of crazy. Tangents and intersections and stuff there, right? Here's the backstory. We knew we got attacked at Pearl Harbor by the Japanese air raid. Afterwards, you do a little like debriefing to sort of figure out how the heck did that happen, right? The Army and I guess I don't even know if the Air Force existed at that point yet. I think it was still a division of the Army. They came in and they said, well, what happened? You go to your radio operators, the people who are on the. Remember we have like the old radar screen. You get the little blip and the little line walks across this, and it goes in the circle. And it's like tick, tick, beep, and whenever you're detecting planes coming in, everybody on board with that old school idea, a little black and green like Atari looking screen. So they said, they go to the radio operators, they're like, dude, you guys kind of missed a big thing here. Like, we had a bunch of kamikaze attacks. Why didn't you guys see the planes? Turns out what happened is they did see the planes on the radar. But it was such an absurd idea that they would get attacked by kamikazes. They thought it was a flock of birds or something. They thought that the radar will detect too, right? So the radar's dumb, right? It's like MATLAB. It just does what we tell it to do. And we say detect stuff in the air, so it detects stuff in the air, and it's up to the radio operator, receiver, the receiver of that radio signal, right, to pay attention to the screen and decide, are these birds or are they planes? Now they happen to have made a grave mistake in this particular situation. It led a lot of cognitive psychology research into how do those mistakes get made, and they're really interested in fixing that, right? So when you're detecting that and you see and you call it accurately for what it is, which isn't what happened, right? But if they would have seen those blips and said, oh, those are a plane, based on this, what we call these receiver operating characteristics or signal detection, you're trying to detect the signal on that screen, we call that a hit. So it's an accurate hit. Okay? So this would be like calling these guys. They'd both be hits. One would be a high confidence hit, the other would be a low confidence hit. They would both be successfully identifying old items. Now, what if you have an old item, and its status is old, but you call it new, which would be over here. What would you call that? You missed it. Yes. So again, within our detecting a signal framework, sitting on your radio operators, you missed what you were supposed to hit. All right. Now we switch gears. Now the status is actually our new items. Let's say you have a new item, but you go, yeah, I remember that. What might we categorize that condition as? Huh?
Yes.
Is it a miss? This attribution is right on track. We use that to actually refer to the source memory stuff where you misattribute one source to another, but you're right on track. We'll call it a false alarm. It's kind of like pulling a fire alarm. You're like, there's a fire, we'll get it, bring out. There's no fire, right? So let's just call that false. False alarm. Now, what would you say fits in this condition? You have an item that's truly new in our memory test, but now we also accurately say it is new. So you're still back on this side of the scale. It's not quite a hit, because a hit usually refers to something like you successfully identified the target. And so our target during a memory task is basically like, try to hit the old items. And I know that might sound a little wonky and whatnot, but you're on target in the sense, no pun intended. you're right on the right track. We just need to call it something else so that when we compare these conditions, we're not stuck by saying we compare hits to hits.
Rejection.
Yeah, you're correctly rejecting this new item as accurately being something that's new and rejecting it from being a hit. You guys follow the logic? Okay. Correct. Reject. Okay, it's like the All-American Rejects or something like that. All right, so now we got our 4 things. When we try to look at the brain activity for conscious items, or excuse me, let me rephrase that. When we try to look at the brain activity for conscious memory processes, usually what we've been using is hits versus, I'll abbreviate correct rejections as CRs. Okie doke? So the reason that this is a useful comparison is because you're comparing accurate memory with accurate non-memory. Now you could compare hits to misses or hits to false alarms or other things, right? Because again, we could compare accurate memory compared to essentially a false memory, the stuff that they didn't remember. But what's nice and best about this comparison is both of those responses are accurate. And so you're not confounded with the variable of accuracy, right? So it's not just, you're holding that constant, so you're not just comparing things you remember to things that you don't remember, but you're also, but what it is something better, because you're saying things you remember correctly versus things that you don't remember correctly. Does that make sense? I know we're getting into some wonky cognitive psychology here, but I did say we cross a lot of bounds. Okay, so this is one way to do sort of what we might call explicit memory. Now the question, and this is what we've been working for, is how do we study implicit memory? How do we use these types of responses to give us leverage to taking a peek inside the window of the unconscious mind? What did you study?
Misses minus correct rejection.
All right, misses minus correct rejections. Okay, so miss minus or versus correct rejections. So, can anybody come up with some logic as to why that is an effective measurement to give us some insight into unconscious processing? It was your idea.
Yeah, I'm trying to find it in my paper.
It's good we wrote it down, right?
Yeah.
How about this? When you have a miss, what is it telling us? It says that the person thought that it was new. Right? If they thought it was new, did they remember it from the past? No. They're like, this wasn't studied. If somebody says they correctly, if there's a correct rejection, what did happen? What did they say in their response?
They remember it not being there?
No, they said the same flipping thing. They said this is new. I don't remember this. Both of these have the identical subjective report from the subjects. They're telling you the identical conscious experience of memory, which is, I don't have a conscious experience of memory. This is a new thing. Right? So what you've done is you've held, now you can compare these two conditions against each other, with which factor held constant. Your conscious experience is held identical between the two. Okay? So if we create a little bar graph here, okay? Let's just call this spell that right. I don't have enough coffee this morning. Subjective reports. This is your subjective reports, okay? Your consciousness. Okay. You guys follow? Okay. So, if these are our bar graphs here, and this is our subjective reports, there is no difference between that factor, is there? Okay, cool. However, we can make another bar graph. All right? Let's call this brain activity. Okay? And we will make it look a little different. These are equivalent, right? No difference. Okay, here, or what we can say, they're equal. On this one, we can label it, let's say, miss and correct rejection. Okay? Here we have our conscious subjective reports, right? People self-reporting, telling you what their experience in their mind. On the right-hand side, we have a measurement of the biological activity of the brain. So we have the mind, then we have the brain. Okay, can you see? Get this thing out of the way a little bit. Okay. What?
What did you say about that? Like the 2 bars on the first graph?
Here, this is consciousness.
Okay.
Here, I'll erase that. That's too much there. Subjective reports, conscious subjective reports. And we can relabel this the mind. And we'll call this here as the brain. Right? Because we have both. We have our mind telling us what, or the subject's mind telling us what they think is happening. And then we have the brain telling us what is happening. Right? Perception versus reality. Right? We're not going to go too deep into the matrix today. But somebody told me once, don't take the red pill, or is it the blue pill? One of the two, right? So, we have equivalent measures of conscious reports by comparing misses to correct rejections. But what happens if we could see the... So in theory, the brain activity should be also equivalent. Right? However, what happens, what can we do and say if that's not the case? What if we don't see it equivalent, but instead it's not? And there's a difference between misses and correct rejections. What would you say?
But there is a significant difference between brain processes and a unconscious memory versus conscious memory.
Indeed. And what I say is that the brain is remembering what the mind has forgotten. Does that make sense? Kind of? Yes.
Is that is it usually that there's more activity when it comes to the miss conditions?
Well, maybe, maybe not. We have to look.
Okay.
In some cases it would be, other cases maybe not. And in sometimes that might be the case. In other times it might not. Here's what I mean by times. Different milliseconds of our epoch. Right? Because we know this stuff is always moving around. Make sense?
And it varies spatially also.
Huh?
It varies spatially also.
Yeah, well, those differences that might happen at different times might happen at different places too. So what we can do is if we wanted to study implicit memory, you could study this condition here, which is also one that I've already programmed, I believe, into your bin operations file for you. So that's a couple of ways we can start navigating our way through making hypotheses and things like that, is thinking about thinking about the strategies of what these different conditions reflect and represent cognitively, that we can then make some hypotheses about how we can mine the data of the mind. And so I mentioned the first day of class, one of the goals that I have for this class is essentially to try to get people sort of trained up to a point to where you can compete for a job and say, yeah, I can join your lab, I can join your company, and on day one you can give me data and I can give you results. I know how to work with the data. I know how to program it, I know how to work with it, and I know how to extract meaningful results. In that situation, right, we have this backward sort of process or sequence from what we normally expect. We didn't make the hypotheses. We didn't even run or collect the data. We show up and they've got these piles of data that they've had sitting around for a couple of years that they just need to hire somebody to analyze. And you're like, well, okay, I'll have to, unfortunately, I can't start from ground zero of coming up with hypotheses first, but instead we have the data that we have to then data mine, essentially, with your own hypotheses. So it's a very reasonable normative experience, actually, that happens fairly more frequently than you might think. Does that stuff make sense? So if we start thinking about this gives you guys a lot of clues about ways to come up with more hypotheses in the future and start digging into the data in any way your heart's desire. Sound cool? Any questions on this stuff? Okay. Oh, man, I talked so long the computer screen went off, huh? Let's see if I can log in here again. All right, so let's see here. We talked about methods, correct injections, we talked about all that stuff. So was there any other questions or experiences writing anybody wanted to share or have questions about? Okay. And what we might do later is I might give you a whole different set of data. We'll see. We'll see what happens later on in the semester. I'm not sure. We're very fluid and responsive to what you guys would like and prefer to do because we have a lot of flexibility in this class. But one idea that I'm kicking around is, and this is we've never done this before in the classes. I'll give you a whole new set of data. It has nothing to do with the data that we've done here. Maybe later on in April or something like that. It's actually a data set of people recognizing faces. And you all right? Okay. And I won't write an events list. I won't write a sorry. Bin operations file. I know it's horrible, right? You're like, oh, make it stop. Oh, what a world. We haven't done it. I'm just kicking around the idea. We'll see how we feel in terms of comfortability as we get to that point. But that would be kind of exciting to be able to bridge towards. But we'll see. Maybe I won't. Just look. Here's the benefit of that. You don't have to keep working with the same data all semester. You can bridge out and do something new and different, right? Which is actually something that people ask for last classes too, right? Because this can get kind of dreary at times. You get working on the same stuff, but there's a lot of stuff to work on. You know, you guys had what, 60 some odd possible people to choose from in your subjects. Some of them include people who have hippocampal damage, other people are middle-aged, other ones are 2 different data sets of healthy young college students. So you guys actually have 4 separate data sets already. But maybe it's useful, maybe you just find this stuff boring, we might go to some face memory stuff. Anyways, we'll talk about that later, if we're so inclined. But if that's something that's interesting for you, let me know, because I would like feedback about if that would be something that would be fun, and we can work our way through that. So, keep that in mind, because we can use this same framework too, because it is a memory task, and we can look at hits, misses, correct rejections, false alarms, and all that kind of good stuff for different types of face, like eyewitness memory stuff. It's kind of cool. That's conversation for like April or something. Yeah, doesn't seem like a March type of thing, does it? Doesn't have that ring to it. It doesn't generate that like St. Patrick's Day vibe. Yeah, it's definitely not a spring break type of thing. I feel you. Okay. Alrighty, let's see here. So everybody got their papers in and all that good stuff, yeah. Outside of creating hypotheses, was there anything that you struggled with in terms of working with the data at home?
While working with the data,
Mm-hmm.
I mean, I've had MATLAB problems, but
On your home computer?
yeah,
Is it a desktop or a laptop?
the laptop fixed the Mac, but I'm on the El Capitan or whatever, so it's an OS, but basically like all my.
Did you download everything according to
I did. I was gonna talk to you about it later, but that's the only issue I had. I mean, my bin, all the bin files, I said they all flatlined, so I didn't really have much to go with.
I see.
Yeah,
Well, it's important if you have that laptop to bring it.
yeah, I do, yeah.
You did?
Yeah.
Okay, yeah, so that's what you should be working on. So if you have your own laptop, it should look like that fine gentleman there with your desktop computer screen down and working on your laptop. Because that way it won't get confusing. First of all, we can help and we can work on whatever problems are, but we can also make sure that it becomes less confusing between two different computers that you have to work between.
I just don't think the MATLAB software really works well on Mac at all.
Mm.
It's not working for me.
So it's a compatibility issue. It's not that it doesn't work with Mac.
Yeah.
MATLAB makes a lot of money by making sure that they work with Mac. So you just
Yeah.
have to find the right version.
I mean, I downloaded all the versions.
Okay.
They're still not working.
So what you should do is you should go online and look for bug reports.
Yeah.
There'll be things that say exactly like what you guys are saying, like, oh my gosh, I had Mac OS version, blah, 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 MATLAB version, blah, 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 is not working with it, what do I do? Like, people have already done this. So you have to go out, and then if that doesn't work, MATLAB, it's a very expensive software, which means it have really good tech support.
Yeah.
Because
Is
if people are paying thousands of dollars for the software, you can be damn sure that they're gonna want somebody to be able to walk
Yeah.
through.
So the MATLAB support will be and we can help with that too.
Yeah.
That's why I say like you did, you brought your laptop, because that gives us something I can tangibly sit down and fix that with you. The MATLAB should be the easiest thing to resolve, because what you said is a commercial product. There is an enormous wealth of resources. I mean, that stuff, the actual system itself with the software, that should be working. And if it's not, that's a very resolvable thing. And from that, then it's just making sure we have the right setup of the EEG Lab software plugins for it, which is also really well supported too. So we can sort that stuff out. So I'm glad to know about that, because those are easy targets for us to hover over and make sure we really fix and do well. So thank you for mentioning that. We will I will talk with you guys in a couple minutes about that individually. So that's one thing. So did everybody try making results sections? Work with the data at home, try to get some results that we're able to talk about? Anybody?
Yes.
Some people did? Okay. So what I want to do today is basically revisit that. You okay? Okay. I didn't know. You look scared.
No.
Okay. Don't be scared. It's okay. We're gentle. I just wanted to revisit some of those results. I know we went through it very quickly. Oh, so did anybody do the extra credit?
Was it due today?
I thought it was, throughout the semester.
Yeah, we're,
Yeah, I mean, I guess I didn't formally say it was due today. I just asked if you did it. I also didn't say that. Did you?
we tried screencasting and it was a disaster.
Is it? Yeah. Yeah. I mean, it's like things are always a little tougher than we might think, right?
Yeah.
So you guys can appreciate then when people ask me to screencast, and I'm like, oh, I'm working on it, right? Okay, I'm doing the best I can here for you guys. Okay, it's not as easy as you might think, right? And so, yeah, hopefully, please take advantage of that, because the stuff that we talked about, let's say at the end of last class, how to make results, how to extract results, that's all in there. That's all on the video that I posted, right? But it sure would be nice to see the screen a lot more clearly. So you can listen to me auditorily walk you through again by going back to that last lecture. God bless you. But I wanted to revisit it a little bit today, so we're going to go faster than we did last class on extracting results because we can. And I wanted to basically do a couple things. We're going to go through how to
extract our statistics, and then also how to make our figures, because that's the other part that's important for a results section. Okay? So, when we're writing lab reports, hopefully now you guys have an appreciation of the different sections that need to be written and how it can be challenging to write those different sections. And so I'm going to try to help lend some insight into ways that we can do that well, right? So we started with an intro, okay, and we did our methods. Now methods are going to include subsections of participants, procedures. What else do we have in there? The actual participants, procedure, analysis, data analysis, or data acquisition and data analysis. Okay. So acquisition is particular to a lot of the neuroscience studies, fMRI, EEG, other types of things that we're going to acquire with, as opposed to behaviorally, and then our data analysis approach, etc. Okay, then of course we're coming to our results. Now usually in these types of results you would have two big subsections, right? Behavior, and physiology. Okay, so we would first talk about our behavioral response data. Yes?
Oh, sorry, before we go to results, one of the critiques that I always get is that I don't make a good distinction between study design and experimental setup. So I was going to ask Eric, but if you could address it too, that would be helpful.
It's difficult to address without seeing what you did.
Oh, okay.
But study design is basically, well, I guess there's different ways that you can think about it, depending on who's asking the question. But, you know, is it within subjects, between subjects, types of approaches, versus, you said experimental paradigm?
Experimental setup.
So one could think of the experimental setup as, you know, the more detailed aspect of, say, we had an encoding phase that varied in the task they were doing, and then we later had a retrieval phase that asked for heightened confidence followed by source confidence, as distinguished from the other type of more like overarching type of design, which is like we did within subjects or between subjects design. So this isn't a research methods class, you know, purely, so we're not going to dive into those details and all that kind of stuff. But you can see that the type of ways that I described it in my paper doesn't actually have to get into all those details in particular. So we're not going to talk a lot about writing behavioral results in this class because it's not a class about behavioral results. This is lab methods in human neuroscience. So we're going to talk a lot. All you have to do is write lab results for the physiology. Now, if you're so inclined later on, you might even start to add a third part, which might look at relationship. We won't even do that. So we won't even correlate stuff. We can do that later. And then, of course, later on we'll get to discussion, which is going to have your conclusions, etc. And one thing that we mentioned earlier that we didn't have in today's assignment was all the way at the beginning we have an abstract. Okay, so hopefully you guys have seen abstracts before if you've read some of these papers or other things for other classes. You know, it's basically a one-paragraph summary of everything. Okay, so an easy way to think about that is 2 sentences for each section. 2 sentences of introduction, 2 sections of methods, 2 sentences of results, and 1 or 2 sentences of discussion. That's a really easy way to frame it and approach it. Okay. Now, when you do write the 2 sentences for results in your abstract, all right, these are not the mathematical sentences that we talked about in the real results section. Now, those 2 sentences in the abstract are not like t equals 2.54, p equals, no. That stuff actually goes in this section. In the abstract, you just say what the actual result was. This is exhibited more positive activity at midline posterior sites during early time latencies and greater activity than correct rejections during that time period. That's a result that you would say in the abstract without the statistics and all that jargon stuff. And then you would draw a conclusion that says, it seems like neuropsychological patients might have an impairment in implicit memory processing during early temporal latencies. And that would be your interpretation of what the result finding was. Okay, doke. So, we have all this good stuff, and what I want to do today is we will talk. Oh, sorry. This is the other thing I want to have. We need figures. We need pictures. All right. So our figures, we're going to follow a very simple model. Okay, that people find really useful in this class, and it's going to help us to communicate the results that we find mathematically really well in the writing. Okie doke. Here's what we'll do. Okay, we'll start with a topographic map of our condition, and you'll have your latency. Okay, so let's say 400 to 600 milliseconds. Okay, and so you have your topo map. Okay, and that will tell you, you'll label it with the type of condition that you have too. So let's say we talked about misses, minus, correct rejections. Okay, then you might say, well, we're going to look at this electrode site in the head. So we're going to start really big and whittle down really narrow in our conceptual approach to this. Okay, so here we're starting macroscopically, the whole freaking brain, whole scalp. All right, now we already know how to make scalp maps because we practiced that a couple times. We'll go back to it and you'll see what I mean. Now we're going to get more narrow. So we're going to do Drake started at the bottom. We're not starting at the bottom. We're starting at the top because screw Drake. Right? He dances bad anyways. He does. You can see it in the videos. It's awful. He dances like this. It's bad. So we don't want to be like Drake, right? We want to actually be cool. So we're starting at the top, and we'll work more narrow. So now we take, instead of the physiology all across the scalp, now let's take the physiology for the single electrode site that we care about, our electrode of interest, that you can make your own hypotheses about and pick your own electrodes about. Okay? And now let's look at the actual ERP for that. Okay? So we have your topo map here. Now you have your ERP. Okay? So the ERP, right, it's going to have our standard plot. All right? We have your pre-stimulus baseline period here. It's kind of oscillating. Whoop. Right? Now you're going to have condition. Let's just call, actually, your first condition in this case, we'll call it, since we're talking about misses and correct rejections, maybe that's our miss. Okay? And then you have your other one. And we'll call this one your correct rejection. Okay? So we have a figure now that has two components. We have our topo, and then we have our direct electrophysiology at one sample site. Okay? It includes the labels of what we're looking at. So you have a little legend that shows you what each one is. Okay? And this is time in milliseconds. And this is essentially what amounts to mu volts. Mu is a tiny, tiny little version of microvolts. Okay, so it's an order of magnitude smaller than microvolts. Mu is a little Greek sign. And I'll show you how to get that too if you want to in Microsoft Word. So we want to label these axes. Okay? And we have time here. So you also want to put, and this program will do this for you, you have little ticks marks showing 100, 200, 300, 400, whatever. It shows you the time. You guys have all seen some ERP plots by now, so you know that they make this for us. But I'm just showing the important parts to make sure that we do include on these figures. And what's actually can be really helpful is to then cue your reader in. So just like here, we have our topo map, and then we cue them into, like, we're going to look at this spot. Well, now, what do we want to cue their attention to within this figure? How about our latency of interest that we're actually measuring?
right? So this shows the whole head, but only in a window of time, right? This shows the whole time that we need to take that window of. Does that make sense? Okay, so one thing that I find helpful when I write this stuff and I make these figures, and I think that if you, so maybe you guys have taken a look at some of the papers that we've posted online, maybe as readers you find it helpful to have that little cue in to where you should pay attention on the thing. So I like to make a little like box around whatever difference, whatever time we're looking at where there's a difference between our two conditions. You guys follow? That's helpful, I think. Okay, cool. So now we've worked from the top, we've broken it down to a single electrode point. Now one thing that's also useful is to show, and we've seen this before, show a little inset of the head that shows what label we have there. And so let's say we call this one, you label this one for electrode PZ. Z, of course, meaning our midline. You guys remember the International 1020 system? Awesome. All right, so now we have this framework. What do you think we could use this space for up here? We want to add 1/3 aspect of a figure to report what we found. Yes, sir?
A bar graph?
A bar graph, yeah. Perfect. A bar graph of what?
The difference waves.
Well, you could do a bar graph of the difference waves. The difference wave is, of course, the subtraction between the two. But usually, what we'll do for this class, and what I think is going to be more useful, is how about a bar graph of just not the difference between the two, but the bar graph of each of the two conditions so that the reader can see what the difference is. Basically the same thing that we showed down on this bottom side about a half hour ago when we talked about that difference in physiology. So let's say, so see how we started macro? We got a little bit more micro. Let's just take this little window that we've now zoomed in on, and let's make a graph that we have, let's say, miss and correct rejections. And we'll say, we'll give it a title. Graphs need titles. So we'll call it, whatever, mean, amplitude, PZ, 400 to 600 milliseconds. Okay? And on our y-axis is going to be our mu volts, right? So we label what we have there. You'll have little tick marks along the line. Okay? Now, this is basically going to be our correct rejections and our misses. So our correct rejections here, that's going to be reflected here. So this is, let's say, what that is. So it's a little bit more positive there. Okay? Now our misses are even greater amplitude or here, right? So that's going to be a little greater. So you draw a bar graph just like you suggested. And now we've really narrowed in and zoomed in on exactly what. Yes, sir?
Sometimes I see on bar graphs the little, I think they're called error bars.
Exactly.
I don't know what those are.
Error bars, we'll get to those too. Those are really useful too. So they help us to see, so this is the average, mean, across all of our subjects. Okay? Now some subjects you're going to have a lot of variability in, right? Some subjects might have a big, huge thing and a smaller value for another condition or another subject. And so the error bars gives us a snapshot of what that variance is, right? So what we ideally would like are very small error bars where it looks like this, right? Because that says that this average amplitude here is pretty consistent across subject because it doesn't typically vary between these really close points, as opposed to an error bar that came down here and another one that popped up here. If they're overlapping like this, that gives us a sign that maybe these aren't so different. The averages average differently, but there's so much variability between subjects, maybe the statistics won't pan out. So what we want to see is really tight error bars. That's always really nice to see. Okay? So we have that. We have our error bars, and I'll show you guys how to do all this today so you can make these nice figures. And what we'll have then is we will, one thing that's really nice, and I think the readers tend to find it very helpful, is if we then cue them in with a little bracket that shows between this and this condition, we put a little asterisk if it happens to be statistically significant. Yeah?
Because then we know, like, okay, they actually ran the test and they're telling us this difference is meaningful. Okay? So what we have here is 3 different figures. Let's take this. Now we have figure 1, and we can call this panel A, B, and C. Actually, just for teaching purposes, I'll put usually you put those panel letterings up on the top. So we'll take that, we'll put it panel A, panel B, and panel C. Okay, so you have figure 1A, 1B, 1C. All one figure, even though it's actually 3 combined. But it kind of makes the story easy to digest for the reader, right? Because this is all telling the same story. Right? We look at the big effect of memory all across the scalp, zoom into a representative site to see the direct physiology of those 2 conditions, and then zoom in to see the latency of interest. So you have time, space, and the ERP. Does that sound pretty good? Okay, cool. That's what I wanted to cover today, and showing how to pull this information out, how to make these figures. That way, you guys can do it. Maybe you guys want to take a break before we embark on the MATLAB section? Okay, let's do it.
I got to making scalp maps. I didn't get stuff.
That's okay. I mean, it's a good opportunity to practice and set that, foundation. And,
Right.
We built this stuff.
Is that your paper?
Yeah.
Oh, it's very nice. I would just, my wife changed the line.
Well, this happened. This wasn't how it was originally. I changed some stuff this morning, and it happened at my incident like that. It was originally more like that, but then I.
Yeah, it looks very professional.